So what is pyroaerobiology?
So pyroaerobiology is really exactly what the words sound like.
Okay.
And what we're doing is looking at the intersection of fire, things that we find in the air, so aerosols, and biology. So what it really is an intersection of the way that microbes, including things like fungi and bacteria, are aerosolized in wildland fire smoke, and understanding the biology of that and what it means for human life and what it means for ecosystems.
Oh my goodness, okay. And this is something that you actually discovered, or you created the term, right?
Yeah, we needed a way to talk about it, so we came up with a term. We realized a few years ago that this was a phenomenon that had not been explored. And there was an initial study in 2004 that had hinted at this being something that was happening. Mm-hmm. And so we just kind of followed up on that and did a lot of initial experiments to find out whether or not this was happening. So is it possible that fires are producing microbes when they produce smoke? And do these microbes actually survive the combustion processes that they go through and make it into the smoke plume long enough to be transported to other places?
Okay, so then within the smoke plumes, what type of organisms do you find?
So we find a wide variety of different types of organisms. So we have, at this point in time, been able to identify using DNA analysis about 3,000 to 5,000 different bacteria.
Oh my goodness.
And many hundreds of fungi. And it is common for a lot of organisms to be in the air at all times. So any day that you're breathing air, you're also breathing in some microorganisms. But the concentrations and the diversity that we find in smoke is much, much higher than what we find in ambient air conditions.
Okay, so are these organisms then that are kind of produced by the chemical process of burn and then fire? Or are they ones that exist and they just kind of change through that process? Do we know that yet?
So we have just started to uncover that. So
Wow.
We've started some research that looks at the relationship between the things that are burning, what microbes are in those things that are burning, and then what we find in the smoke. And it looks like there's a pretty tight relationship between those things.
Wow.
So that means that the kind of microorganisms that are on the surfaces of plants, things that get kind of picked up by the wind, those are in ambient conditions. Mm-hmm. But what we find in smoke from wildfires is that soils also get mixed up because there's a lot of wind that's created by the convective winds of, mm-hmm. of a wildfire. And the organisms that are inside plants also get exposed to aerosolization because the plants are being broken down during the combustion process. So we get a lot more organisms, different types of organisms, wow. And some of those organisms might have consequences for downwind.
Okay, and explain that. So why is pyroaerobiology so important when it comes to wildfires and the impact of smoke, right? I mean, we have a lot of wildfires here in Idaho. We know that smoke can impact air quality, mm-hmm. makes people with sensitive, immune systems have issues, can make general population, depending on how bad the air quality is, have issues. But let's talk about those organisms in the smoke. What kind of impacts can they be having?
So that's exactly what we're trying to find out. Okay. So we are really at the very beginning of understanding what pyroaerobiology means for human health. With that higher concentration of organisms in comparison to ambient air characteristics, what that suggests to us is that people are breathing in a lot more than they would be in normal times when there's smoke in the air. And we of course know that smoke in general has some significant health consequences. Especially for people who are immunocompromised or already have some kind of respiratory ailments. Mm-hmm. So the fact that along with the particulate matter that's in smoke, there are microorganisms mm-hmm. that are not normally in the background air conditions suggests to us that there could be some impact on human health.
Wow.
And that's something that we're investigating right now.
That is phenomenal. Okay, and with this type of research, can you tell where smoke comes from?
That is a wonderful question because I love to think about smoke as having a genetic fingerprint.
Yeah.
And that genetic fingerprint would be associated with the source materials that are producing that smoke. So that is something that we're exploring too. The atmosphere is a very complex place.
Yes.
So everything is getting mixed up all the time. But we've been able, like I mentioned, to track some of the source materials and how they relate to the DNA in the smoke. And it seems like that relationship is pretty close. So we're thinking that potentially we can use that kind of indication, understanding the composition of smoke, as a way to understand what different sources of smoke are contributing to the smoke at a given location. Because of course, as we've all seen this summer throughout the country and throughout the world, smoke is coming from a lot of different places, and in some cases from very far away places.
My goodness, wow. Okay, this is just a great example of the incredible research coming out of the University of Idaho and the, if you will, trails that are being blazed in certain areas. Especially, I am so flattered and honored to meet you because this is incredibly exciting. If people want to learn more and hear about pyroaerobiology, where do they go?
You could find all sorts of information on the UIdaho website, so uidaho.edu/CNR for the College of Natural Resources. And then we are located in the Coeur d'Alene Harbor Center, so the Coeur d'Alene campus of the University of Idaho. And we have our research facility, our lab there. So there's a lot of information on that website as well.
Oh my goodness, I know there's so much more to talk about with you. I mean, a whole team going into this research and just, oh, there's so much. That's why I'm gonna go and look it up online as well. Thank you so much. I greatly appreciate your time.
Thank you for having me.